everyone. For sequence a sub n, with our first term is 1, and we have a sub n plus 1 is equal to 3 to the power of n times a sub n for n greater than or equal to 1. We're going to find a rule for the nth term and the value of n such that a sub n equals, and there's a little typo here, this should be 3 to the power of 66. Alright, so let's look and see what we have and see the pattern. So let's look at a sub n plus 1 equals 3 to the power of n times a sub n. Alright, we already know that a sub 1 equals 1. Now, what I'm going to do is let n equal 1. If n is 1, I'm going to get a sub 2 equals 3 to the power of 1 times a sub 1. And if n equals 2, I'm going to get a sub 3 equals 3 squared times a sub 2. If n equals 3, I'm going to get a sub 4 equals 3 to the power of 3 times a sub 3. And then if, let's see, 3 purple, n equals 4, that's going to be a sub 5 equals 3 to the power of 4 times a sub 4. Now let's compare these numbers. These are always the same, and they're one less than this n number. So I can write my formula as a sub n equals 3 to the power of n minus 1 times a sub n minus 1. So therefore, what I'm going to have is a sub n equals my first term times 3 to the power of 1 times 3 squared times 3 cubed times 3 to the 4th, and just put dot dot dot, times 3 to the power of n minus 1. Alright, since my a is 1, I can change this to 1 and write my a sub n equals, and factor out this 3, or basically we're writing this as, this is the same base, so I'm going to write this as 3, and this would be 1 plus 2 plus 3 plus dot 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 plus n minus 1. Now this gives me this formula here, right? This is for k. So basically what I can do is write my formula now as 3, and looking at this, I'm going to substitute n minus 1 into each of these n's. So that's going to give me, if I substitute n minus 1 here, I get n minus 1. If I substitute n minus 1 into this one, I just get n, and then divide by 2. And again, I'm using this formula here. Alright, so now that we have this, we're going to look at this. Alright, so basically, we have a sub n equals 3 to the power of 66. We also have a sub n equals 3 to the power of n minus 1 times n divided by 2. Since my bases match, I just set 66 equals n minus 1 times n divided by 2, or I can write this as n minus 1 times n equals 132. Now you can do the quadratic thing and factor, or we can just note that if you already know that 11 times 12 is 132, that's a little easier. And that's going to give me, this is your n. So it says find the value of n. So n equals 12. All right. Another approach that's a lot faster, I wanted to show you this approach because that's where the quadratic formula comes in. Let's let a sub n equal 3 to the power of 0, 3 to the power of 1, 3 to the power of 3, and then we have 3 to the power of 10. All right, 6 and then 10. So basically, I'm just substituting everything in. So basically, that would mean B sub n equals 0, 1, 3, 6, and 10. And this new sequence is created by powers. So I'm basically using these powers. All right. And then using the quadratic model, we're still going to use this formula. So we can write this as B sub n equals, you always take your first term, plus, and then we're going to do the sum from k equals 1. And for the quadratic model, you have to put n minus 1 here, k. So the k part is going to be n minus 1 times n divided by 2. So therefore, your a sub n would equal, since we did the different sequence, 3 to the power of n minus 1 times n divided by 2. All right, that's just another approach. Thank you. Have a nice day. Bye-bye.